Hey everybody, it's Dr. J, and today we're talking about entropy. Let's talk chemistry. I want to give you guys 4 guidelines for entropy, alright? Let's look at the very first one. Entropy increases as one goes from a solid to a liquid, alright? Or if you go from a liquid to a gas, especially going from a liquid to gas. So basically, as you go to a gas phase, your entropy is increasing, right? And if we look over here to this chart, entropy increases as it goes up, temperature's increasing as we go towards the right? We can see that at zero, right, at that crystal, at 0 Kelvin, etc., we know that it's defined thanks to our third law of thermodynamics. So we got a definition. At zero solid, 0 Kelvin, we got zero entropy. Now from here, right, as we increase our energy or temperature, right, the solid will then turn to a liquid. And then we can see as it turns to a liquid, what do we see about this phase? The phases, we can see that the liquid phase has a higher entropy than our solid phases. And then once again, if we transition again, right, phase transition to gas, we can see that that gas phase is a very high entropy compared to our solids and liquids, right? So essentially, you want to know this trend, right? Entropy increases as you go from solid to gas. All right, everybody, I'm down here. What's up? Let's look at the second one. I said 4, but it's actually 2. Okay, so entropy increases if a solid or liquid is being dissolved in the solvent. All right, so essentially, this is straightforward. If you're dissolving anything in the solvent, that means that you're going to be increasing your entropy. All right. Third, entropy increases as the number of particles in a system increases. So if we look at this example here, I go from N2O4, entropy of 304 joules over Kelvin, to 2NO2. So in this case, we've increased the number of our particles, one from 1 to 2. So our entropy level has actually increased. These first 3 guidelines that I have given you are going to be very important for as far as when you're evaluating your delta entropy over a reaction. Okay, so this is going to be very important. Now I want to give you guys some other guidelines that can also help you with entropy. So now let's talk about some more guidelines in this case when we're comparing our entropy of individual molecules. So let's look at number 4, right? Entropy increases as the complexity, right? Either the number of atoms or the number of heavier atoms or whatever of a molecule increases. So let's just look at the first one and the last one. Methane, CH4, we can see that entropy is going to be 186. Very simple compound, right? Single bonds right there. As you increase, right, how complex, either by the number of atoms or if they're heavier, whatever, right? But if you increase the complexity of them, what do we notice here, right? The entropy has increased for each one. If we look at propane, right, we got 3 different carbons bound to a lot of different hydrogens, right? We could see, right, that the entropy has increased from these 2. All right, now it's not significant, but we can see that it's increase in entropy based on how complex it is. The 5th guideline, right, once again, we're comparing to each other. Entropy increases as the mass of the molecule increases. So we look at this example over here, right? If we look at chlorine and fluorine, we can see in this case that the mass of chlorine is bigger than fluorine, and because it's going to be bigger, then our entropy level for chlorine will be a little bit bigger than our fluorine in this case. All right, so entropy increases as the mass of your molecule increases. If we look at 6, entropy is higher for weakly bonded compounds than for compounds with strong covalent bonds. So when we look at graphite versus diamond, both of them still are carbon at the end of the day, but how they're bound is going to be very different. In this case, graphite, weakly bound. Because it's weakly bound, it's going to be a lot easier to break those compounds. And because it's easier to break those compounds, then it's going to be easier to disperse that energy. And if you are easier to disperse that energy, right, then your entropy is probably going to be higher. Okay. So essentially, that's the key thing, right? You got weak bonds, expect a higher energy. Okay. And then lastly, the entropy of any material increases with increasing temperature. All right, so as you increase your temperature, you're going to probably increase your entropy. And then this is just the last thing I want to sum up for entropy, guys. When we're talking about individual molecules, the higher the entropy, that means that more likely the molecule will want to fall apart, right? As we mentioned, weak bonds, it's probably going to be easier to break those bonds. All right, so think about these different things when you're comparing your entropies, and I will see you guys next time in our videos.